Okay, so this is section 6-2, and now we're talking about the law of cosines. We're still talking about solving triangles, but we're talking about a few different cases. Now we're looking at triangles where we're given a side, an angle between those two sides, and then another side. We're also looking at side, side, side. Now we have different directions for these two different setups. Typically, if you have SAS, you want to solve for the angle that you have to solve for first, and then the smallest one, and that'll make sense in our next example. If you have side, 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 you want to solve for the biggest angle first. And remember, that is the biggest angle is across from the biggest side. These same two notes are right here. I just want to make sure we point those out and remember the process for those two situations. So let's look at our first example. We have a triangle ABC, and we know that angle A is 120. We have side B is 7 and side C is 8. And then this is little a. So let's go ahead and fill in the information we know. And side B is 7 and side C is 8. So the reason we can't use the law of sines is because we don't have a matching pair anywhere. We don't have this side, we don't have this, we don't have this. So the only thing I can do right now is use the law of cosine. The law of cosine is written up here, and really this is the same thing but just set up differently depending on which one we're looking at. Now, it makes most sense for us to solve for side A since that's what we have here, so that's what we're going to use. So I have A squared is equal to B squared, so 7 squared plus 8 squared minus 2 times 7 times 8 times cosine of A, which is 120. And then it's just a matter of simplifying all this information. This is 113 minus 112 times cosine of 120. And when I type all of that in my calculator, I have A squared equals 169. So A equals 13. Well, now I have a matching pair, so I can solve for my missing angles here using the law of sines. So now I want to solve for, since I have a side and angle on the side, I want to solve for side C, or I'm sorry, angle C. So sine of C over side C, which is 8, equals sine of 120 over 13. So sine of C is equal to 8 sine 120 over 13. Angle C, when I do inverse sine of all of this, is going to give me 32 degrees. So this is 32. And it makes sense. Let's see. Yeah, we'll get to that in the next angle here. So angle B would then be 180 minus 32 minus 120, and that would be 28 degrees. And you want to make sure that this information makes sense here. Our smallest angle should be B, since that's our smallest side, and it is our smallest. Then this one's bigger, and then this is our largest. Okay. Let's move on to our next example. Now we're given 3 sides, so we're going to use the side, side, side method. We know that side A is 6, side B is 9, and side C is 4. And so we can fill in that information. A is 6, B is 9, C is 4. And now we're solving for all of these angles. Well, again, in side, 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 you want to solve for the biggest angle first. So our biggest angle would be B. So B squared equals A squared plus C squared minus 2AC cosine B. And we are going to plug in all the stuff we know. 9 squared equals 6 squared plus 4 squared minus 2 times 6 times 4 cosine B. And this is where people start to make mistakes. I need to subtract this stuff over, so let me just simplify this here. We have 81 equals 52 minus 48 cosine B. So the mistake a lot of students make here is subtracting 52 minus 48. That 48 is attached to this. I can't subtract that. I need to subtract 52 from both sides. So 29 equals negative 48 cosine B. Dividing by 48, cosine B equals negative 29 over 48. So inverse cosine tells me angle B is about 127. Okay. So 127 is angle B. And now I can use the law of sines to find one of my other ones. The next biggest one is this one. So sine of A is over 6 equals sine of 127 over 9. And sine of A is equal to 6 sine 127 over 9. Angle A, when we plug in our calculator, gives us about 32 degrees. And then subtracting, we can get angle C is equal to 21 degrees. Okay, so that's the law of cosines. And the law of cosines leads us to another formula to find the area of a triangle. Now you're familiar with the area of a triangle being 1/2 base times height. But what if we don't know the base or the height? We can use what's called Heron's formula, and that gives us a new formula for finding the area of a triangle. Now S is called our half perimeter, sometimes called a semi-perimeter. We add all 3 sides up and divide by 2. That gives us this S value. Now once we have that S value, S times S minus A times S minus B times S minus C gives us the area of the triangle. So let's go ahead and do that in an example here. It says find the area of a triangle with A equals 6, B equals 16, and C equals 18. So first we need to find S. And adding all of those up, dividing by 2, we get 20. And then the area is going to be equal to 20 times 20 minus 6 times 20 minus 16 times 20 minus 18. And that gives us, when you multiply all those out, we have 20 times 14 times 4 times 2. And that gives us 47 meters squared. And that's our area. And that brings us to the end of section 2.